Welcome to the third lecture on early life, from the first organisms forward in evolution. This lecture is going to focus on classification. I'm Wendy Nofke and I'll be giving you your presentation today. Taxonomy is the science of classifying organisms, and it's helpful to understand present diversity and the past evolutionary history. What we've used for several years is the Linnaean classification system. This was developed by Carolus Linnaeus in the 1700s, and it grouped organisms that shared obvious traits. We had a hierarchy of groupings that started with the kingdoms, phylum, class, order, family, genus, and species. The species was the most exclusive grouping, and these were organisms that were similar enough to produce fertile offspring. We also use a system of binomial nomenclature. It gives each species a unique two-word Latin name with a genus and species name. This will uniquely identify the species, so it's similar to having a first and a last name for a human. There have been revisions in the Linnaean classification system. It was originally published in the 1700s. Since then, new species have been discovered, and the biochemistry has become known of many of the organisms, so it's needed some revision. We've added the domain, which is larger than the kingdom, and we have three different domains. We have the bacteria, the archaea, and the eukarya. So with these three domains of life, the bacteria, archaea, and the eukarya, both the bacteria and archaea are single-celled organisms that are prokaryotes. The eukarya is going to consist of the animals, plants, fungi, and protists. And there will be several subcategories within these three domains. Phylogeny is the evolutionary history of a group of related organisms, and this can be shown in a phylogenetic tree. This classification system started to be used after Darwin published his theory of evolution in the 1800s. Here we create clades, or groups of organisms, that include the ancestor and all of its descendants, and it's represented by a cladogram. The cladogram can show evolutionary relationships among reptiles, mammals, and birds that are massed in the separate classes of the Linnaean system. So this is an example of a phylogenetic tree where you have an ancestral eukaryote and it coming up with its different groups. You can see where each branch comes out and then the two sub-branches. This branch, you had more different sub-branches that were created over here on the right. With this example of a cladogram, you can see where you have the ancestor down here. As you move out further, the further down the line, the later these diverged from their common ancestor. So these are earlier divergences from the common ancestor. These are later divergences.